Good morning, 7th grade. This is surface area of pyramids and cones, which you will find on page 615. So for the lateral surface area, and the lateral surface area is the surface area of everything, all the faces except for the base of this pyramid. So you have the length of the base. Let's say it is 8, and you have the part called the slant height, and the slant height is the height of each face. And this works for a regular pyramid. So if everything is the same, all the sides of the base are the same, and all of the edges and everything, the slant height's the same. Make this 4, for example, for my example now. And the formula is over here. This is half of the perimeter of the base times the slant height. So the perimeter would be 8. So if it's a square pyramid like this one is, then I have 4 times 8, that would be 32, times the 4, and then times 1/2 or divided by 2. So I'm going to cancel this out, and there, and just make that a 16. 16 times 4 is 64. So 64, that would be just the lateral surface area. Now let's see if that makes sense, because we have 4 triangles here. We have 1, 2, 3, 4. So 4 faces, and we know that the area of one of these is base times height divided by 2. 8 times 4 is 32, divided by 2 is 16. That means each one is 16. And we have 4 of those. 16 times 4, 64. So that shows you how that works. Now, for the total surface area, then you would just need to add the area of the base. So the way the book does that for the formula is the 1/2 the perimeter times the slant height plus b the area of the base. So that would be S surface area. So you have the difference here between lateral surface area and total surface area. Now we already know that this one here with that example was 64. The area of the base, well, let's see, if it's 8 on each side, that'd be 64 plus 64. That would be 128. Let's make them feet. Feet squared, because this is just surface area, this is not volume. Now this one, I've tried to make a pentagonal pyramid right here, and the example in your book on page 616 actually tells you the area of the base, 27.5, and this is centimeters squared. So they don't even make you figure out the area of the base, they just tell you what it is. Now for each of the faces, we have, since it's a regular pentagon, we have a side length of 4, and the slant height is 15. It looks like, yep, 15. So if I make my dotted line here down the side, that right there is going to be 15 for your slant height, giving the right angle down there at the bottom. So again, the lateral is 1/2 the perimeter times the slant height, and then we have to add the area of the base, which they already told us is right there. So let's see the perimeter. Let's see, 4, 4, 4, 4, 4. 5 times 4, that's 20. It'd be half of 20 times 15. Well, that's 10 times 15, that's 150. That would be the lateral surface area. So just the lateral surface area, 150. And then you add to that 27.5, and you get 177.5 centimeters squared. That is the total surface area. Now it's time for the surface area of a cone. So again, we have the lateral surface area and then we have the total surface area, which for this total surface area we would just again add the area of the base. Now the base of this is a circle, so the area of a circle is pi r squared. So I'm going to put pi r squared here plus whatever the lateral surface area is, and we'll get that in a minute. So for the lateral surface area, it's pi times r times L. So just pi times the radius times the slant height, which in a pyramid, in a cone is just the distance up the side. They're all a slant height. Alright, so it looks like I'm going to do 3.14159 times 7.3 times 11.6. Alright, now if I put that all into my calculator, I will get, and I'm going to use the pi button, pi times 7.3 times 11.6. So for the lateral surface area of a cone, of this cone, I get 266. And they're using feet squared. Now, for the total surface area, and if I add this here, pi r L, we already know that's 266. All I need to do to that is I need to do pi times 7.3, that is the radius, 7.3 squared equals going to be 167.4, and I add that to the 266, and the total surface area should be 433.4 feet squared. Okay, here's a look at some of the homework. So I'm going to put my formulas up here again for everything. Oh, and there they are. So for the pyramid, it's 1/2 perimeter times the slant height, and I put plus the area of the base in parentheses in case you need the total surface area. And for the cone, pi r slant height, pi r L, and then I put plus pi r squared in parentheses. So let's take a quick look at these problems here and see what you think. Number 10, square pyramids. We're using this here, base side length 8.4. Okay, so that'll help me since it's a square pyramid. I know it's going to be 8.4 times 8.4 for the area. Perimeter, let's see, that would be a bunch of 8.4s, right? That's a square pyramid. And then the slant height, that's pretty straightforward. 11 has the cone, you got the radius and the slant height, no problem. Number 12, we have the cone. Again, we have a diameter. Oh, be careful. Slant height, there you go. Alright, let's see. Number 13, square pyramid. 5 feet on each side, so again, that will be, that's going to help you do your base. And also the perimeter. Make sure you know how many sides on a square. Slant height again. Find the lateral area. Only the lateral area there. These three would want the total surface area, I'm guessing. Okay, cone-shaped icicle dipped in frosting. Woohoo! 1 centimeter in diameter. Slant height is that. Total surface area. Alright. What does it have to do with icicles and frosting? I don't know. Anyway. Number 15. The Great Pyramid. Base of each side is 230 meters. And the height is 187 meters. Find the total surface area. Okay, the base of each side. So that would be, because if it's a Great Pyramid, that's going to be a square pyramid. The height from the base to the face, along the face to the top, is 187. So that's the slant height there then, right? Okay, well, I don't see anything too weird there. That should be pretty good. Alright, problem solving side. I've got my formulas up here again. Let's see, Good Time Company needs to make paper hats. Paper hats are shaped of a cone. Alright, we're in business. Radius, Slant height, great. How many square centimeters of paper you need to make a check? So you need, yeah, I don't know. Do you think you need paper to make the base of a paper hat? I don't know. Gee, I think you'd want to put it on. Number 2, let's see, TP, approximately the shape of a cone. He has 290 square feet of canvas. The diameter is 12. What will the slant height be if he uses all the canvas? And there's no floor, so that means you just need the lateral surface area. So that one is a pretty good one, because that would say we have 290. That would be the lateral surface area. Pi, and then I lost the diameter is 12. I'm guessing then radius must be 6. And you have L. So you're solving for L there. I think you can do that. Divide by some stuff, get rid of it next to the L. There you go. Make my stuff disappear. There we go. Number 3, okay, so we have this metal scoop, correct amount of food, shaped like a cone, dimension how much metal was used to make the scoop. You're giving giving food to your horse. I'm pretty sure that the opening there is going to be open, but you still need to know that. But sounds like, to make that scoop, that sounds like lateral surface area only on that, I would think. Alright, then this fun thing here, surface area of the water tank. Has a roof, but they want the surface area of the whole tank. So first we have the pyramid there. It's supposed to be a square pyramid. That doesn't look like a square because it's 10 on each side. But so you've got your lateral surface area of that. No base in that though for the surface area, because the base would be down here on the rectangle, or the rectangular prism. So let's see, how much are these sides going to be? Don't forget to add those sides in there too. There you go, that's that part. We got 2 more and then we're done. Alright, here we go. Smile Time Ice Cream Company, and sell their ice cream cones instead of cylindrically shaped cups. Surface area of each container. No top on either container. It's nice of them to say that. Surface area of each container. So here we have the surface area of the whoa, move that guy. Surface area of the cylinder, surface area of the cone. So you also have to look back and get your formulas for that to make sure you know how to do that. You just need the slant or the lateral surface area for that, and then you need the surface area for that without the top. Interesting. Wonder which one wins. Alright, then you have to refer to the diagrams in number 5. That would be these over here. 90 cents. How much does Smile Time save every time for every 100 cups? So, 90 cents per square foot. You have to figure out how much each one costs in square inches. It is square feet though, and they want to buy 100 cups. So there you go. See how it goes.